Okay, we are back again. Today we're going to talk about balancing equations. Now, just to recap, the previous lesson was about conservation of mass. Now, it's important to understand that before we can start talking about balancing equations, because you need to understand that whatever's on the reactant side of a chemical reaction needs to be accounted for on the product side, even though it's changed form, even though chemical reactions have occurred, but the numbers have to add up, and that's what conservation of mass teaches us. Right, now let's look at how we actually balance equations. So I want to show you a simple example. Right, first of all, we've got carbon plus oxygen. Now carbon plus oxygen produces carbon dioxide. We would say that is a word equation. So if we were to write down the word equation, we would say carbon plus oxygen produces, the arrow shows it produces, never say equals. I see many students saying that or writing that down, carbon dioxide. Okay, now there's your word equation. Now just to put an S there, because carbon's a solid, oxygen is a gas, okay, and we're producing a gas, so it shows that the chemical reactions occurring here. Okay, now that is your word equation. Now to balance it, to do a balanced equation, we need to make sure the right number of atoms are on each side of the equation. So as you can see here, we've got one carbon, which is stated here. We've got 2 oxygen atoms, and everything is accounted for here, so we can tick that. So that's a balanced equation there. Now let's look at another example. So if we have hydrogen, okay, we write down hydrogen plus oxygen, okay, and this produces H2O. Now the reason why I put 2's here is because both molecules are diatomic. They're found naturally bonded together, so they come as a pair, as we would say. Now here, it's worth mentioning now here that this small number, we noticed it's at the bottom right hand side of each atom, this small number, we call this the subscript. Okay, now diatomic molecules like so, subscripts, we can't change that. That's what is already written down. We can't make that number up. We can't juggle around with that number. Okay, so H2 and O2, if you look at the product so far, you'll see that the numbers don't add up, because we have 2 hydrogens and 2 oxygens, a total of 4 atoms. Okay, but here we have 2 hydrogens in the product side there, but only 1 oxygen. So how can we tackle this to balance it? So my suggestion, first of all, is always to, what's missing? Oxygen. Let's put a 2 in front of there. Okay, we can add numbers in front. Remember, we can't create subscripts, so that's a subscript. Okay, and the number that we put in front of the atom, the larger number, we call it coefficient. Okay, just some terminology there for you. So now I've added 2 on there. That satisfies the 2 oxygens, so we're happy here now. But 2 times 2 gives 4 hydrogens. Okay, so I would have to put a 2 there. Now if I balance or add the numbers up, now we have 4 hydrogens. I'm just going to write that down there, 4 hydrogens in the product side. We can tick that off. I'm happy. 2 oxygens, okay, and 2 oxygens here. I can tick that off. I'm happy. Okay, now let's look at a slightly more complicated one. So if we have methane, which is CH4, plus, that's a 4, plus oxygen. Okay, this produces, it's a combustion reaction, so we're going to get carbon dioxide plus water. Okay, now I'm just going to pause it there for a second. I'd like you guys to see if you can balance it while I just make this look a bit neater. So you got your methane plus oxygen, and it produces carbon dioxide plus water. Now what you need to look at is the numbers. So at the moment, is everything balanced? I have 4 hydrogens on the methane side, okay, 4 hydrogens, but I only have 2 here. So how can I balance that? If I put the coefficient of 2 there, that satisfies the hydrogens. Now if I look at the total number of oxygens, because carbon's 1, I've not even talked about it because there's 1 on both sides. I'm happy with that so far. So if I look at the total number of oxygens, I have 2 times 1, which is 2, plus the 2 here, which is 4. I only have 2 on this side, so coefficient of 2. Now if I look at everything, 4 hydrogens, 4 hydrogens, 4 oxygens, 4 oxygens, balanced. So I hope that makes sense. Now let's practice what we're preaching. Let's look at an exam question. So here's an exam question from the AQA website, and here's another one. I'm just gonna let you guys have a go at this. Pause it for a second on your screens, and then we'll talk about how to balance this. So here we go again. Now I'm looking at this equation now, the first one, and the first thing that stands out for me is Cl. Okay, on the product side I can see 4 atoms. Okay, here on the reactant side there's only 1. Let me just speculate and put 4 there. How does that change things? So while I've put a 4 there, I've satisfied the chlorines, but now I have 4 hydrogens, only 2 on the product side. If I do this, will that work out? Let's look at the GEs, the germanium, 1 and 1. So that I'm happy. 1, 1, 4 chlorine, fluorine, happy, 4 hydrogen. Okay. Yep, I'll give it a tick for hydrogen. This leaves the oxygen. I hope that adds up. 2 times 1 is 2 oxygen, and 2 oxygen there. Perfect. Now let's look at this second one. A bit more complicated. So the first thing I'm looking at is iron. There's 2 ions here, iron atoms, only 1 here. That's a simple fix. If I put 2 there, that satisfies that. But look at the brackets now. The sulfur or the sulfate ion here, this is the sulfate ion, by the way, it's SO4. Now there's 3 of them, so that means there's 3 sulfur atoms and 3 O4 oxygen atoms. So what can I do with this? If I put a 3 here in the coefficient for the H2SO4, which is sulfuric acid, okay, now that satisfies this component here, okay, but now we have 6 hydrogens. How do I get 6 hydrogens here? By putting a 3 there. Now 2 iron, 3 sulfuric acid, and then 3 hydrogen molecules. Does that make sense? I add it all up, 3, 6 hydrogens, and let me write that down here for clarity. 6 hydrogens, tick them off. 2 Fe and 2 Fe here, I can tick that off. We have 3 sulfates here. Remember, this is the line for the products. and the reactants, 3 sulfates, okay, 3 of them, and 3 sulfates here. Yep, that satisfies it, and there's your balanced equation. So hopefully balancing equations makes a bit more sense for you guys now, and it just takes practice. More practice you do, my advice always is to leave the oxygens, if there is an oxygen element in there, at the end, and try to balance the let's say the carbons or the ions or the germaniums or the bigger molecules first, and a bit of trial and error, a bit of practice, and you can get these done easily. Okay, that's me over and now, and I'll see you in the next one.